Okay, so now we have a way of actually measuring the steepness of lines by looking at the change in y over the change in x, okay? Or delta y over delta x, or rise over run, however you want to think about it. Now let's think about the interpretation of different values for the slope and their effects on the graphs. So let me just show you a whole bunch of these things really fast and get a sense of this. I look at this line here, this red line, and what I see is that thing is positively sloped. It's going up, it's increasing. If the line is increasing, that means the slope is positive. So the slope of this line, rise over run, it'll be a positive number. But if I look at this, I actually see it's not going to be too positive, because this slope, the diagonal right between, that has slope 1. We saw that earlier. So the fact that this is less steep means this slope is positive, but less than 1. Positive, less than 1, going up, but not very steep. Okay, what about this one? Well, this is a vertical line. It's perfectly vertical, which means there's no change in x. So when we have rise over run, no one's running. No running, which means we have a 0 in the denominator, which means the slope of this is undefined. We have something over 0. So this is a vertical line, slope undefined. Okay? How about this one? Well, this slope actually would be negative because the line is decreasing. The line is falling. So since this function is decreasing, it has negative slope. It's going down. And in fact, you can see visually that it looks like it's right in between. It's perfectly diagonal. So in fact, this slope would be -1. This would have slope -1. Okay? Let's see this one. This slope is what? Well, it's perfectly horizontal. This is a horizontal line, which means that there's no change in the y. There's no rise to put over the run. So in fact, the rise would be 0. So 0 over anything is 0. So this has slope 0. Horizontal line, slope is 0. Okay? You see how we're measuring steepness by looking at the slope. Okay, this line is fairly steep in a positive direction. It's going up, so it's going to have positive slope. How does it compare to 1? Well, let's take a look and see. This looks like it has slope 1. So this looks a little bit less steep than this. So my guess is this is a number just a little bit less than 1. So it's still increasing, so it's positive, but it's not very steep. What about this one? Well, this would have slope that would be negative of some kind. Negative because it's going down. Slope is down. And so what we see here is that if the slope is positive, then we know it's going to be going in an upward direction, like this. If the slope is negative, then we know it's going to be going in a downward direction. And the greater the actual value is, the steeper. So for example, a very, very large sloped thing will be very, very steep, approaching something that's undefined. And a very highly negative valued thing would have a very steep slope this way. This might have slope, for example, like -1,000. A big, big value with a negative sign in front of it. Okay? So that sort of explains how these things look. Let me just show you on this big grid line so you get a sense of how these things go. So as the slope of a horizontal line is 0, and as the slope becomes more and more steep, the line becomes more and more steep, the slope becomes larger and larger and larger. This has a very large slope. This has even a larger slope because it's steeper. Once we get to this point, in fact, it's undefined. It's too large. You think of it as infinite, but don't. It's really, really large. But the moment I cross that, now it becomes extremely large, but in a negative direction. These are all now negatively sloped lines. These all have negative slopes, and now we're back to a 0 slope line. So you get a sense of how the numerical value of the slope interacts with the actual visual interpretation of a line.